If you're here for lateral thinking, how to build the impossible in SketchUp, you're in the right place. If you're not, I'll still let you stay, but you may not enjoy it as much as the session you thought you were going to. So that's okay. Welcome, everybody. Glad to see you at Basecamp. If you enjoy the keynote, I think you're going to enjoy some of the stuff I have to talk about. There's a lot of parallels there with what Grant talked about. My name is Dave Cooperstein. I am an architect and senior creative designer at a firm called PGAV Destinations. We specialize in entertainment destination attractions all over the world. So we do theme parks and zoos and aquariums, cultural destinations, museum exhibits, science centers, anything and everything that you plan your vacation around, we design. If you've ever been to SeaWorld or Busch Gardens, you've been to one of our projects. If you've been to the Georgia Aquarium in Atlanta, you've been to one of our projects. We have projects all over the world. And I have played many, many roles at the firm. I've been there for 20 years. I got there right out of grad school. And I've been a master planner and graphic designer and architectural designer and illustrator and all the things you see up there. I also have a question for you. Does anyone know the best way to kill a circus? You go for the juggler. Like, it's right up there on the screen. So you walked in on that one. All right, so here's what we're going to talk about today. I'm going to talk a little bit about sort of the way we think. I've got a story to tell you. I'm going to ask you sort of a few questions about what you see. And I'm going to talk about a concept called lateral thinking, which is the title of this presentation, so hopefully I'll talk about it. I'm going to talk about what it is and how you use it, how I use it, how we sort of use it. And I've got two examples that I'll walk you through. One's a turtle restaurant, and one is a sort of crystal tower that we designed for a theme park. And I'll take some questions. So it's pretty simple, pretty easy. I've got a lot to cover. I tend to go kind of fast. If I'm going too fast, I'll slow down. Please say something. If you're mean to me, you don't get a prize. If you're nice to me, I'll give you a prize. So the way we think. I'm going to tell you a story. The story is about a company, and there's a trying time in the company's history, and the leaders of the company wanted to know what the outlook for the future was. Is it going to be optimistic, or is it going to be kind of, should we prepare for the worst? So they hired a consultant, and the consultant said, whatever you do, don't hire an economist. Apologies to any economists in the room. But assemble, the consultant told them to assemble as diverse a group of people as you possibly can and draw from the wisdom of the crowds. Get all of their opinions and learn from all these various people from various walks of life. So that's what the consultant did. She brought in people from all across the world, all walks of life. She sat them down in a conference room at a giant table. She put a glass of water in front of them. And she said, optimists tend to see the glass as half full, and pessimists tend to see the glass as half empty. Well, we would like to know what you see. How do you see the glass? And so the survey specialist was first up, and the survey specialist said, I wonder how this glass got half full. Because if we could figure out how the glass got half full, we could get it all the way full. Next around the table was a scientist. And the scientist looked at the glass, and the scientist said, this glass is simply twice as large as it needs to be. Right? The doctor was up next. The doctor said, well, pessimism correlates with stress-related diseases that can shorten your life by up to 20 years. So if you know what's good for you, you had better see this glass as at least half full. Statistician sitting around the table next, and statistician held up a chart, and he said, at no point is the glass precisely half full or half empty because the water is constantly evaporating. And then there was a lawyer, because there always has to be a lawyer. And the lawyer said, we have no comment at this time regarding the fullness or emptiness of this particular glass, of this alleged glass. And there was a new immigrant at the table, and the new immigrant said, where I come from, we have no glasses. We have nothing to put in them, so by comparison, this glass looks very, very, very full. And then there was a former billionaire who had just lost 3/4 of his wealth. And he said, hey, I think that's my glass. Where did you get that glass? And when I last saw it, it was full, and the glass was twice as large. And then there was a politician from the party in power, and he said, despite the fact that the previous administration neglected this glass disgracefully, we have made it a priority to ensure the fullness of all glasses everywhere is and will be maximized. And then there was a politician from the opposing party, and he said, despite the hard work of the citizens of our country, the current administration continues to shamefully allow this glass and all glasses across this great country of ours to be drained to the point of exhaustion. And finally, there was a Taoist at the table, and the Taoist said, this glass is simply what it is, and so is what is contained in it. And the consultant thanked everyone and sort of concluded and dismissed them from the room. And the executive said, well, now we've heard the wisdom of the crowds. Is the glass half full or half empty? And the consultant said, yes. Please let us know if we can be of further assistance in the future. So the glass story is a fantastic demonstration of what's called conditioned or linear thinking, right? On his blog, Paradigm Life, Wade Bohr said, conditioned thinking can often hold us captive. It's the process our brain goes through when it has been exercised repeatedly to think a certain way. So when I put this up on the screen and you look at it, raise your hand if you see a bunch of letters from the middle of the alphabet. It's okay. I can't give you all prizes, but you can raise your hand. And raise your hand if you see water. H2O, water. Right? Does anybody see it yet? 3 degrees below zero. I'll give you a minute. Anybody? Pay through the nose. This one's a little easier. Anybody? Someone just said it. Fork in the road. This one's easy. But on second thought, so all of these are examples of lateral thinking, right? There's a guy named Dr. Edward de Bono, and he's the sort of the father of lateral thinking, for lack of a better term. And he said that lateral thinking is concerned not with playing with the existing pieces, but seeking to change those very pieces. This is a lot what Grant talked about in the keynote, right? And Dr. de Bono really defined this term of lateral thinking, and he developed a whole approach to developing lateral thinking techniques and how to train your brain. And it's really fascinating. He's got a website and he's got books he's written about the whole concept of lateral thinking. But it's not a new concept, right? Before the Earth was a sphere, it was flat. I guess some people still think it's flat, but let's go over that. Before it revolved around the sun, the universe revolved around it, right? And before we had Einstein's relativity, we only had Newton's gravity. As Shane Snow said on Adobe.com, breakthroughs, by their very definition, only occur when assumptions are broken. When you can't imagine how to answer the question, look at the problem sideways and rethink the question. So how does all of this apply to 3D modeling? That's why we're here. And particularly, how does it apply to 3D modeling in SketchUp? When someone puts this on your desk and tells you to put it in SketchUp, where do you start? What do you even do, right? How do you possibly get to this? Well, it's actually what I spend most of my time at PGAV Destinations doing, is trying to figure out how to build the seemingly impossible, right? The really difficult stuff that our designers and architects and industrial designers and creative team have sort of imagined in their brain, and we have to figure out how to build it in SketchUp or Rhino or some other piece of software, and then we have to figure out how to build it in real life. And how do we do that? So I have 3 pieces of advice to sort of jumpstart your lateral thinking, okay? Number 1 is break down the problem into pieces. This is what Grant was talking about also. Because if you break it down into pieces, then you can simplify the problem for each individual piece, and you can solve each problem one by one. And this facilitates trial and error. So it allows you to make mistakes with one piece without messing up the rest of the pieces. Second tip I have is to expand your modeling tool set. So investigate the tools that you don't often use. This is really important. Ask yourself, can a tool be used for something it wasn't meant to be used for in order to solve this problem? I'll give you a great example. I've read tons of websites and books and articles and gotten advice from lots of people who have an AutoCAD drawing and they want to bring it into SketchUp. They want to bring it in and they want to clean it up. And there's extensions and there's tips and there's ways to take your AutoCAD drawing and do things to the AutoCAD drawing. There's ways to fix it in SketchUp, and I've tried all of them, spent 10, 15 years trying different ways to clean up my AutoCAD drawing. And one day I thought, wait a minute, what if I draw a flat plane on the ground and I put my AutoCAD line work in a group above it and I use the drape tool to drape it down onto the plane. And I draped it down on the plane, and all of a sudden I had this SketchUp geometry that I could now actually work with, and I could just delete the AutoCAD line work, and I had flat AutoCAD line work on my plane in SketchUp. And using the drape tool was the simplest solution that I had never thought about before until I rethought the problem. And another part of this expanding your modeling tool set is learn and use extensions. As Daniel Tall would say, extensions, extensions, extensions. That's my Daniel Tall impression. So it's the best you're gonna get. Learn and use extensions. There's a guy sitting right over there named Justin. Go to his sessions. Justin, stand up for a second. He's right there. You need to go to his session and learn to use extensions. Justin Geis, he's got websites and blogs, and extensions are the key to unlocking a lot of the power of SketchUp when you're trying to build really, really complicated things. My third piece of advice is to rethink how the pieces fit together, right? So once you've simplified the problem and you've solved all of these individual pieces, ask yourself, do they have to fit back together in the same way you took them apart? Can you put them back together in a better way? And do they even have to be put back together? Like sometimes keeping them separate as separate pieces allows for the flexibility in design. That's my sort of theoretical speak about how I approach modeling. I'm going to show you 2 examples. I'll show them to you live. I've set them up in a way that hopefully will make it go relatively quickly, but I've got 2 examples. One is a turtle restaurant. Let me be clear, this is not a restaurant that serves turtle. It is a restaurant that literally looks like a turtle. This is welcome to my world. This is the type of thing that I have to build every day. And the other one is a crystal tower. It's sort of this tapering, rotating tower of video screens that is sitting on top of a glass-enclosed crystal palace-looking thing. It posed a number of really difficult challenges that I think you'll get something out of. So I'm just going to jump over to SketchUp. I've got both those models open. If you're looking on the stick of knowledge, if you came in late, these are not on the stick of knowledge for a number of reasons. One of them is we do a lot of really confidential work, and I just wanted to keep it nice and clean and easy, and so I didn't distribute them. But anyway, this is Shelley. I named him Shelley after I modeled him, and because he's a turtle. Why did nobody laugh? Because that's a funny joke. Oh, I have the wrong one up. That's why nobody laughed. Oh, that's good. You know what? I have to close my PowerPoint. Well, that makes me feel way better because I thought that was a really funny joke. Hold on a minute. Hold on a minute. You don't see him there. There he is. There's Shelley. That's Shelley. There we go. Thanks. All right. Wow, it's going to be a long session. Okay. Oh, good. I got plenty of time here. All right. So, like I said, this was a design that we did for a park. And all of the buildings around the park, the client wanted them to look and be themed like animals. There's a fish restaurant, there's a turtle restaurant, there was an egret restaurant. And I had to build this thing in SketchUp. And this is what I was given when I started. I was given this beautiful drawing from one of our designers. And what I can only assume one of my architectural colleagues decided was a plan and a section. That's what I had. And I was supposed to put this thing in SketchUp because we were required by contract to provide the client with a model, a 3D model of the entire park. And so I had to figure out how to do this. And I said, okay, well, I've got the section and I've got the plan, so let's just start. And maybe I can just kind of define the shell shape, the shell framework of this thing, using just the plan and the section. I knew where the columns lines were going to be because my architectural colleague graciously put the column lines in for me. So I knew where the column lines needed to be. So I knew that's where arcs had to be, and I knew that that's where the section needed to go. So I started to define that shell, right? And then I said, okay, well, maybe I need to tilt it up because that's what the designers of this building wanted. They wanted this turtle that wasn't flat and he's sort of coming up out of the ground with his little babies on his back. So I tilted that bad boy up, and I had my shell in SketchUp. And so I had at least the framework, right? So I've broken this thing down into the very simplest form that starts to define what this is, right? So then I needed to make the shell. And it wasn't as simple as just clicking on a new tab and the shell was there. So how did I make that shell? Well, there's a fantastic extension called Extrude Tools. Everybody write that down. Everyone's writing down Extrude Tools. I'm going to attempt to demonstrate it. I always get nervous attempting to demonstrate extensions in a session, as Justin knows. But first I got to find my Extrude Tools. I put them over here. So I'll attempt to demonstrate it just so you guys can see. So one of the Extrude Tools is, where is it? Extrude by, now I forget which one I used. Extrude, nope, it was Extrude by Edges by Loft, right? So now I click that tool and I pick these guys that I had already defined. Click that, this is the exciting part. Oops, that was not an edge, so it beeped at me like that. I'm worried this is going to take a while, so I define that, hit enter, segments per section, 24, sure. And then we wait. It says down in the corner, you can see it's making its mesh. I'm really nervous about this. Don't worry, it's not locked up. I think it's in the middle of making it. All goes right. I just got a new computer about a month ago, and so it's pretty powerful. But I'm very nervous that this is going to take a while. But anyway, Extrude Tools is a whole suite of tools that allows you to do things like lofting. It allows you to define a set of edges and skin those edges. There's the number of other extensions that do that. But Extrude Tools is really powerful. It allows you to lay things around an axis. This is taking way longer than I thought it was going to take. So I might be canceling this and reopening the file. Let's just see. Let's hope. Let's cross our fingers. Oh, there's a question. Yes. Extrude Tools is by, Justin, do you remember? TIG. TIG makes Extrude Tools. You can get it on the Sketchucation store. And if you don't have an account at Sketchucation, I highly recommend it if you're looking for some of the most powerful extensions out there. The Sketchucation store has it. There it is. It did it. Woohoo! Now you'll notice it made 10,368 faces. So it's big, right? And I don't want to turn them into quads because that would take a while. Do I want to smooth it? I could smooth it. I'm not going to do it just because it'll take a while. Do I want to erase the original 10 curves? I'm not going to do that. So anyway, so here's my shell, right? I made my shell there. And let me go back to the shell. You can see what it looked like on the turtle. So there he was. So I had my shell. I guess I forgot on that, the one I just demonstrated, I forgot to select the last one, so I didn't make this little piece down here. But anyway, there's the shell. So I had my shell, and then I said, okay, I need to thicken this thing, right? Because it's a turtle shell. We're going to actually build this structure, so it's got to have a thickness, right? It's got to have a roof structure, and I have to thicken it. So how am I going to do that? There's another fantastic extension out there, ironically called Shell. So I grabbed the Shell extension, and I came up here and come down to Shell. And you'll notice right now, it's giving me a little preview. It's 0.15. Let's make it a meter thick. Make it 1 meter thick. It'll give me a little preview. That was a little big, but I'll just do it anyway. I think it's working. Yep, it's working. But anyway, so Shell actually takes your surface and makes a shell out of it. It gives it a thickness, connects the edges back. Boom, there it is. There's a shell. Now I got a little anomaly here, and you can come in here and actually show your hidden lines and delete that and clean it up. And I probably had to do that the first time I made this. But so there was the shell, okay? And so I had, oops, sorry about that. So I had my shell, and the next thing I said is, well, look, it's a turtle. It's got this cool pattern. Our designers drew this pattern on it, and I need to have this pattern. Well, how am I going to do that? Because this whole thing is curved, right? If I go and I try and use the line tool on a curved surface, it doesn't work. It draws across the surface. It doesn't draw along the surface. Well, there's another fantastic extension called Tools on Surface that allows you to draw on a curved surface. This is sort of mind-blowing, but Tools on Surface. So I came out here and I grabbed the Tools on Surface pen, right? And if I click, and it's actually curving the line along the surface, which is absolutely fantastic. And if I did it right, there it is, right? And then, as part of Tools on Surface, there's an offset. I take that. Oops, that's not it. Hold on, I got to select it first. Like that, and there's an offset on surface. I take that and I can offset that. Boom, there it is. And so now whoa, mind blown, right? So I've got that, and so eventually I had my completed pattern, right? I had that shell there with its surface, and so there he was. I did it in place, and then I said, okay, well, I want to give him some texture. I want to give that shell some texture, right? And again, I'm just breaking the problem down into individual parts and solving for each individual part. And that's the key to sort of thinking about how to model really difficult things. So I needed to give him a texture. And so how did I do that? Well, there's another fantastic plugin called Joint PushPull, also available on Sketchucation. And Joint PushPull allows you to push and pull curved surfaces. And so I grabbed this guy, and I said, okay, well, let's use that one. And let's pull him up, let's pull him up 0.5 meter, right? And there he is. Go in here, so you can see it put it inside of a group, and there's all kinds of options, and I can show you all those options, but I'll run out of time. But anyway, so I had this texture, right? And I did that for every one of my surfaces, and so I ended up I just pulled all of those individual little shell surfaces up after I did that. And I had my surface texture there. Let's see, what's my time? Looking good, perfect. And so then I said, okay, well, again, I've got to figure out how to build this thing in real life. So it's got to have a structure to it, right? We're not just, I'm working in a realm of theme parks and themed entertainment where we have to actually build the stuff that we're designing. And so I had to figure out the structure, and so I needed a set of ribs, all right? So how did I do that? Well, it was pretty easy because I already had the arcs from how I first defined my shell, and then I used Tools on Surface to offset those arcs so I could get myself another surface defined on that shell, and then I used Joint Push-Pull again to push and pull that surface down. And so I think, let's say, I'll just use the same one. I'll come in here. And I can actually pull this down, and then you can define how far you want it, and I'll do 0.5 again. But there it is, and it made a kind of a rib under there, right? It made this rib, right? And so I had a set of ribs back there underneath my shell. And now I went to the next problem, and I said, okay, this is a structure, so I've got ribs, so I need something to brace that structure, because I'm trained as an architect. I work in an office full of architects. got to figure out how to actually make this thing. So I need to brace that structure. So it needs a set of ribs, right? Well, that was actually relatively easy because I had already defined the ellipse that formed kind of the bottom plane of this thing. So then it was just your standard offsetting, right? I could just offset that thing, and then I could just push-pull that, and I could just make a whole set of ribs that way. So I made those ribs, and I just scaled the ellipse down, and I just moved it up and made another set, and just kept doing that until I had this structure underneath. And then I needed to get the bottom ribs. And so I did the same thing. I had already defined the bottom of that shell. And so I did the same thing with joint push-pull and some tools on surface, and I made the bottom ribs of that structure, right? So there it was. I already had those shells. I already had those arcs, and so I could make that shell. And so I could create that bottom shell, could use offset and draw lines and tools on surface and create that. And so then I had this completed shell. Okay? And so that was actually the hardest part, was making that shell. From there, it was actually pretty easy. I had to make the heads and the leg. You're saying, well, how is a shell easier than the heads and the leg? Because of an amazing man named Tom, who's here somewhere at the conference, and he has a extension called Sub D. And I think everyone in this room, I'm guessing, could probably model this shape right here, right? It's just, I just drew a flat plane, that's sort of a boxy leg, right? And then I clicked on that and I used his Sub D, and it subdivides and smooths and turned it into a leg. And I did the same thing on his head and on his eyeballs, so I actually just built sort of a boxy representation of his head. And I used Sub D, and there it is. There's his head, I did his eyeballs. And then he has these little babies on his back. So I made a copy of this thing, and I pulled it up, and I scaled it down, and I twisted his legs around, and there was this little guy, and then there was his little brother right there. And you know, these are all components, right? So I can go in there, and if I edit them, they'll all edit together. Components, use a lot of components for repetitive things. Otherwise, group all your geometry. This is a little preview of my session Thursday at 1:15. And then from there, I mean, that was it. That was the hard part, right? Because then I could put the ground in, because our architectural colleague had given me the ground plane. I could put the walls in and the columns in. Stuck that in, pulled everything up. How did I get the ceiling of this thing? Well, I already had defined the bottom of that shell, so I could simply intersect with model and use some push-pulling to give it a thickness. And I had the sort of the ceiling of the restaurant down there. Throw some entourage in there, right? Throw some tables in there. Use Chuck Valley's instant fence and railing. Fantastically powerful. All of Chuck Valley, valleyarchitects.com, V-A-L-I, valleyarchitects.com. He has instant fence and railing, instant walls, instant roof, instant cladding, instant site grader, instant road, and they are amazingly powerful. Again, my session on Thursday will show you how to use instant fence and railing. So throw that in there, and then boom, Shelley had a life, sort of a life of his own. And that is how I sort of broke down the parts and pieces to make this incredibly complicated thing to model way, way simpler. Question?
Yeah, what was that extension they used where it was blocky at first and kind of smoothed out the legs and the face?
Oh, it's called Sub D. Sub D, as in Dave, by Tom. Yeah.
How many hours were you doing?
I'm guessing probably like 3 days, 8 times, 24 hours maybe, from start to finish of just kind of the turtle. There was a lot of prep work trying to figure out how I was going to do it, really think about what parts and pieces. But once I started actually modeling, it was probably 3 days or so. Did it get built? So that's an interesting question. The client decided to go a different direction with the theme of this park. And we actually just put out a press release yesterday for this park. It opened up in China. It's called the Shishui Water Park. And the theme is now all dinosaurs. So it's a dinosaur-themed water park built into the side of a mountain. It is absolutely spectacular. They're going to start construction. They've already started construction on it, and it's going to be something pretty cool. But I also had to model the dinosaurs. And so hopefully 2 years from now, when this thing is built, I'll be able to show all that to you. So that'll be awesome. Little preview of SketchUp Basecamp 2020. Yes, wait, hold on, question.
What's the material that you plan on building?
So most of our themed entertainment work, we have artists that build stuff out of concrete, right? They'll bend the rebar, they'll put a mesh over it, and then they'll spray concrete, and they come in, they carve it, they sculpt it. But we've done stuff out of fiberglass. We had a 60-meter tall whale shark in China that was actually made out of metal panels. So anything and everything to get it to look the way we want it to look. Yeah, what was the question here?
I assume you knew these extensions beforehand.
Yes, absolutely. I did know.
But in your first hand, how did you go by defining what you're looking for as an extension?
How did I define what I was looking for as far as an extension? I've been modeling in SketchUp for almost 15 years, and I've sort of kept up with the extensions, and I watch Justin's videos, and I sort of do a lot of research online, and the best way is to download it and try it out and see what it does. And go online, look it up, and find out. Let me see what time it is before I take more. So, all right, so I got a half hour. I got one more to get to. I'll ask, yeah, go ahead.
So the success of this project comes from the Shelley system. Initially, you had some curves.
Yeah.
How did you get those curves to perfectly be rigged so that when you create the surface, it's nice and smooth?
I basically just drew like I had the column line, and so I drew a plane at that column line, and then I just drew an arc from this column to that column, so I had a nice smooth arc. And I turned up the precision of the arc pretty high. It's still faceted. All the arcs are faceted, but I just turned up the precision pretty high, and then I just drew that arc, and I drew those arcs, and there was a little bit of design work and a little bit of trial and error figuring out, like, should this arc be a little bit taller or wider or whatever, but I knew where those column lines were, and so I knew that the arcs had to get progressively taller to the middle and then smaller in the back, and that's really was the work in defining the shape of that shell. Same thing underneath, too. All right, I'm going to move on. So there's a question there. All right, I'll take one more question. Fine. Dimensions? So it's all built to scale. So we're a full-service architecture firm, and we take this and we'll bring it into our Revit drawings, we'll bring it into our Revit files, and actually define the construction documents and the construction techniques. We have 60 years of experience of drawing themed entertainment, and we're really good at explaining to builders and contractors how to build crazy stuff. And there's a handful of specialized contractors in the world and themed entertainment artists that just understand the techniques for building something like this. All right, I'm going to flip over to my other model because I want to make sure I have time. I should have plenty of time for questions and to give out more prizes because I know everybody wants prizes. So this is a crystal tower, and like I was saying before, this was for a theme park and also in China. And everything in China is bigger. Everything in China, they want more stuff. They want video. It's crazy. It's the Wild West over there. It's amazing. And so this tower was designed to be sort of this beautiful kind of tapering tower with a truss structure inside, with video screens on rotating cylinders. So every video screen, every cylinder would kind of rotate independently of each other, so you could have multiple videos all playing at the same time, and eventually the screens would line up and have one giant video. It was this amazing concept that we came up with, and it all sat on top of this crystal tower, sort of made out of glass. And the idea for this thing was that it was at the center of the park, and it was a fairy tale library, right? So it was this place you would go in the middle of the park where you would learn about all the great fairy tales from the world, okay? And so this is what I was given by one of our senior architects and designers. I was given that drawing. And he had kind of already figured a lot of it out in his brain, but he also kind of hadn't, right? And I had to start figuring out, well, how do I break this thing down into manageable pieces to really make this what he's imagining in his head to be, all right? So it's a little bit, it's symmetrical in plan. It's not really symmetrical in elevation. Part of it is, but the tower isn't. So how do I start to do that? Well, first thing I did is say, okay, well, let's go down to the simplest piece, the structure of this thing. We'll work our way from the inside out, right? Just like you would actually build this piece in real life. We'll go from the inside out. So he had already kind of thought about what the structure would be. And again, I guess he assumed that like this was a good enough architectural drawing for me to figure it out. he kind of had some trusses in there and sort of this Eiffel Tower looking thing. And so I went in here and I just drew some line work and said, okay, and I worked with him back and forth to say, you know, do you think it's this way, that way, how many members of the trust, whatever. So I defined all that line work. And then I had that line work and I used an amazing extension called Lines to Tubes. Lines to Tubes does exactly what it sounds like. It turns any line work into a tube. And so you can start to build some really complicated stuff only by defining the line work. And that's really powerful. So this is Lines to Tubes. So you select all your line work and you go up to here and you say, it's not called Lines to Tubes in the menu. It's called Convert Arcs, Circles, Curves, Lines to Cylinders, which I guess is too long for the Sketchucation warehouse. So it's just called Lines to Tubes is the name of the extension. And do that, and then it gives you some options. Follow me on curves, create group, sure. Each tube is a group. I don't want to make each tube a group. I just want the whole thing to be one group. You can give it a material, and then let's make it like 0.15 meters, and click OK. And pretty quickly, it generates tubes. It says displaying tubes, please wait. All right, there it is. And it turns all of those into tubes. And so I had that, and I made that a component, and I flipped that component over because it's symmetrical. So I had sort of my truss structure, right? And then I went back to the plan that he had given me, and I stood that up. And then I arrayed those, did a radial array. I added some floors, and yes, I know this face is flipped. Don't worry about it, doesn't really matter. Before y'all get on me, I know it's a flip face. But so I added those floors, and I had the structure of this thing. And that was actually pretty simple, right? So now it was a question of, well, how do I skin this thing? So how do I create this skin, which is a series of tapering tubes with sort of concentric radiuses, concentric diameter, and they're also sliced off at weird angles. So how do I do that? So I thought, well, what if I am able to just draw those tapering tubes and just make a tapering tube and then somehow cut them at a diagonal, right? I'm just breaking the problem down into the simplest parts and pieces. So if I can make those tubes, cut them off, I'll have what I need. And so that's what I did, right? So I stood up my sort of tapering section, and I'm actually going to delete that. And then, you know, I can select, oops, I'm going to select my circle down here. I'm going to do a follow me. Oh, I can't do that. Wait, hold on. There we go. Do it this way instead. I'm going to select that circle out there. I'm going to do a follow me. And there it was. And I got to draw a line here, down here to close the bottom, right? And then I could come in here and I can smooth that, soften coplanar. So I had this sort of tapering tube. And now, it was pretty easy. Let me unhide this thing. So then I drew a box at that angle because I had that line. If I hide this for a second, oh, no, it's inside of there. If I hide this, I actually had that line, which I had pulled over from my elevation. And so I was able to draw this box on that plane. And then I just sliced that bad boy off, right? So I went up here, let me get my solid tools out. These are the native solid tools in SketchUp. I use a lot of the native tools. And there's a subtract tool. And oh, wait a minute. It's going to tell me that this one down here is actually not a solid. It's not actually enclosed. That's okay, because I've got a couple tools. One of them is called the Solid Inspector. Solid Inspector will go in there and try and fix it. It says it can't do it, so I've got another tool, and that tool is called Solid Solver. And I got to see if I can find it here. Was it there? Did someone saw it? Someone's pointing. Solid Solver, there it is, Solid Solver. Boom, look, it's now solid. And now I can subtract, right? Let me go out here. I'm going to subtract this one from that one and slice it off. I've got a tapering cylinder that's sliced at this crazy angle. And I did that for all my tubes. Every one of these is that I did the exact same process for every one of those. It's just a different section. The top one I didn't want to slice because I wanted it to be flat. And I had all of those tubes. And then it was a matter of saying, okay, well, wait a minute. I want this thing to be a shell. I used the shell extension again, the same way I demonstrated earlier. So I had this geometry here. I got rid of the top and I got rid of the bottom, and I used the shell extension to make my shell. And then I had all my shells. and it's hollow in the middle because I wanted these things to be video screens with a thickness. And so I put them around my truss structure and gave them a sort of video screen texture. It's actually a glass block texture, so you can see through it. They kind of look like transparent video screens. And there it was. I had that kind of piece to it. But it wasn't done. That was only the tower part. I had to make the top. The top was actually pretty easy because I had the elevation and I could sort of define what the section of that elevation was, and I could rotate that around and do some push-pulling at the top of it, and I could make the top of that section. So I just rotated that about the center point, and then did some push-pulling and some arraying and got the top of that thing. And then the designer said, yeah, but there's this thing I want on top of it. It's this solar orrery. Does anybody know what an orrery is? Oh, someone in the back. You get a prize. Come see me afterwards. A solar orrery. I'll show you what a solar orrery is. A solar orrery is this thing. Of course that's what you want. So I built one, and we looked at it together, worked back and forth, and seemed pretty good. Grab the Buddha from the 3D warehouse. Make use of the 3D warehouse, but please, when you download something from the 3D warehouse, don't just stick it in your model. Go in, clean it up, take only what you need, optimize it, and then put it in your model. Otherwise, your models will start to get very, very, very large. Some of the stuff in the warehouse is beautifully made. Some of it is not so beautifully made. This Buddha was actually pretty good, so I stuck him in there, put some little orbity balls on top of that, and I had the top of my tower. And I had the whole kind of top of my tower. So that's awesome, but I'm not done. Oh, I'm running out of time. I got 20 minutes. So I had to do the base, right? And I knew that it was, oops, wrong one. I knew that it was symmetrical, so I don't have to build the whole thing. I actually only have to build a quarter of it, because then I can mirror that. I can make that a component. I can mirror that, and then I can take all of that, and I can mirror it again, and you'll see that a little bit later on. So the first thing I did is I broke it down and said, okay, well, how do I build just a quarter of this piece? Well, let's start out with just the roof. So I defined kind of the planes that I wanted on that roof, and I worked kind of back and forth with the elevation to connect those arcs. And so I went over to the elevation, and I said, okay, here are the arcs that kind of define the edges of that roof, and I drew those. And I just basically drew the plane between them, and then just like I did before, I drew the arcs along that plane to define those arcs. And then it was a question of, okay, well, now I need to make those surfaces. Well, that's actually pretty easy because there's an extension called Curviloft. And Curviloft allows you to skin surfaces. You click that, and it makes a skin, and it's easy as that. And then I can reverse that, and so there it is. And so I did that for all of the surfaces here. And before I knew it, I had the surfaces for my glass roof. Now, wait a minute, Dave. How did you make those mullions? I'm glad you asked. In order to make those mullions, I figured, well, let me first define the contours of those mullions, because if I can define the contours of those mullions, I can find a way to make a profile along those mullions. But first you have to define them. So how did I do that? Well, that was a little tricky, and this took me a while to kind of figure out. But basically, I took a plane, and I sliced it through. I did intersect with model. Where is it? Intersect with, where to go? There it is, intersect faces, intersect with model, and it runs, and if I delete these, there's the contours of my mullions, right? And I did that across the entire roof. I made this sort of crazy Swiss cheese thing, and if I go and I delete that group, you'll see I had defined all the mullions that way. And it was a little time consuming, it was a little tedious, but I knew where all my mullions needed to be. And then, what do I do with that? Because I need to make them I need to give them some kind of thickness because I want that model. So I had all of them here. So there's one set, and there's the other set. Dale Martins is here, or he's probably at his booth right now or somewhere, but I actually used an early form of Profile Builder. He just released Profile Builder 3, which is astonishingly powerful. This was Profile Builder 1. It still works. It still does much of the same thing. It just doesn't have all the functionality. But I use Profile Builder to say, okay, well, let's define this as a 4 foot by, I don't know, 4 foot by 8 foot, or 4 inch by 8 inch, I guess. It's actually I'm working in meters, so it doesn't come out to that. But I'm going to define that, and boom, I had a mullion. I'm not going to reverse the direction, and I could pick the next one, and I could define that. Nope, and I just did that for all my mullions, and I won't bore you to death with that, but before I knew it, I had defined all my mullions. You could use the lines to tubes, but it doesn't work the same way as Profile Builder. You get some anomalies and some breaks and things. It doesn't always work the same way. Profile Builder is much more robust than lines to tubes, but lines to tubes does work for very simple tubes. When you have 3D contours and things where you've got lots of individual segments, lines to tubes gives you some kind of, you can weld the lines, things like that, but sometimes it gives you some unexpected results. So I had my mullions, and I turned my surfaces into glass, and I had a quarter of my roof. And then I used the mirror tool. If you don't have the mirror extension, get the mirror extension. It's much more powerful than using the -1 when you're scaling, but the mirror extension simply allows you to define the plane upon which you're mirroring. So there it is. Do I want to erase the original? No, and I could do that, and I could take these things, and I could mirror that around, mirror that between here and here, and there, erase the original, nope, and before you knew it, I had a completed roof. And I did some other push-pulling and put some stuff on the roof with little pedestals and things, and then I was almost there, and I put some walls in, and I did some push-pulling, and I used lines to tubes for the mullions, and I put some steps in, some pretty standard SketchUp modeling there, downloaded some little Chinese dragons from the 3D warehouse and stick them on there, but this is a component, and if I show, so there's my component. I only actually modeled a quarter of this thing. And so it went very fast. And if I come into some of these things, you can see all of those are parts and pieces of the component that are then mirrored and mirrored and mirrored. So it all works very well. And then, I needed my little Fairytale characters on top. So I did some very, very careful surfing of the 3D warehouse. I got some beautiful 3D characters. But again, I brought them in, I cleaned them up, I optimized them before I stuck them in my model. So I got all my Fairytale characters. There's a knight, there's a dragon, there's an archer, all kinds of, there's amazing stuff on the 3D warehouse. So I stuck those on there. And then I needed, by the way, this whole thing sits on a bed of water, of course. So I put some water down there because then I needed some bridges. So I put my bridges in. I used instant fence and railing. I grabbed some torches from the 3D warehouse, these beautiful little 3D transparent flames, made some bowls, put the torches on top of my column. And I had that, and then I had my completed tower. But I wasn't quite done because he was the senior architect on this project was very adamant that these screens were video screens, and before we showed it to the client, he wanted to make sure they understood they were video screens. Okay. So I'm going to put some images on them. Well, that was also really interesting because it's pretty easy to project an image onto a curved surface. And so let me hide that. So here's this one, right? So I needed to project an image, so I had my transparent PNG, and I projected that back onto my sort of curved tapering cylinder. Problem is, when you project the transparent PNG, the backside of it is still a color, or still a solid, right? So, and with these video screens, when I have them all layered on top of each other, I don't want to see multiple images showing through. I want to see, essentially, the image on one side only, because you can't see from the back of the video screen, you can't see an image. And so how did I do that? Well, that was easy. I just took this material in the materials manager, and I just made it transparent, right? So I came in here and I turned my opacity down, and I made that transparent. And the material on the front is the image, and the material on the back is transparent. You can do that too if you're working like with houses, and you want to be able to see from outside the house, so you can see inside. You can make one side of the wall transparent and the other side solid, so when you're inside the house, you see a solid wall. When you're outside, you see it transparent, you can see inside of it. How did I project the image? I think there's another way to do it now. When I was building this, I knew you were going to ask me that, and I should have set something up. But basically, I put my PNG in the right place, and then I sampled that texture. So I came here, and I sampled that texture with the little eyedropper. I sampled that, and when I clicked on that cylinder, it projects it back. Right? Makes sense? All right, so, and then, if I unhide, let me hide this guy. Let me go in here and hide this guy. And so then I had all the parts and pieces, and I stuck them all back together, and I had my design. And so before I take questions, I've got about 10 or 11 minutes. Oh, wait a minute. That's not what I wanted to do. I want to get through my little summary here. Here are the key takeaways. My key takeaways, anyway. Change the pieces and rethink the question. Breaking down a problem can simplify things, right? It allows for trial and error. I said this earlier, breakthroughs occur when assumptions are broken. There is a way to solve for any challenge. You just might need to look at it in a different way. And expand your tool set. I get asked a lot, what's your favorite extension? What's the best extension you've ever used? Why do you use SketchUp and someone else in your office is using Rhino and someone else is using Revit and someone using ZBrush and someone's using the newest program that just came out? And I always tell them, the best tool is the tool you need to get your job done. So if there's an extension that can help you get your job done, use it. If we get a graduate who comes out of school who's a whiz in Rhino, I'm not going to make him use SketchUp if he can build it 10 times faster in Rhino. The challenge is making sure that he understands how his model is going to be used later on down the pipeline, so that when he's building it, I know I can take that geometry and pull it into SketchUp and use it for what I need in SketchUp. And I understand that whatever I'm building in SketchUp is going to eventually end up into Revit because we're making construction documents to tell the contractors how to build this thing. So I need to make sure that I understand this is going to go into Revit, and how do I optimize my model and my geometry for it to go into Revit. That's all I have for you. Here's how you can reach me. There's my email address. There's our website. Come to my workshop if I haven't mentioned it before. Speed Up, Tips and Tricks for Faster Modeling. It's at 1:15 on Thursday. You can also reach me on Twitter, but I don't think anyone uses Twitter anymore. You can reach me on Instagram, but I never post to Instagram. You can get me on Facebook, but I won't friend you because I only friend my personal friends. And you get me on LinkedIn, but I probably won't remember who you are. But you're welcome to connect with me. That's it. That's all I have. I have some time for questions. Oh, they're applying. Thank you. Yes. How large are my files? It depends. I mean, I can work with files. I mean, I've worked with files hundreds of megabytes, 300-400 megabytes. If I'm doing an entire theme park, 300-500 megabytes. It just requires more computing power. Yeah, it's just computing power. And I work for a big firm, so we have the resources to buy faster computers and better computers and more server space and all that stuff. So it's not so bad. Look, someone from work is calling me right now. Oh well. Yeah, there's a question there. I'll get back to you. The extensions, most of the extensions I mentioned are free. Almost all of them are free. The Instant Suite, Instant Fence and Railing, it's like $20 a year. But most of the extensions I mentioned are free. I'll come see me for a t-shirt, and you come see me for a t-shirt. Yeah, what's your question? Oh, Solid Inspector and then Solid Solver. Yeah, Solid Solver. I'll have to look. Justin, you remember? Justin, is Solid Solver in the warehouse or Sketchucation? I'm not sure. I'll have to look. I'll have to think about that. I mean, I do, but maybe come talk to me afterwards. Yeah? Question. Come see me for a t-shirt afterwards. Yeah. You, back there. Yep. What advice do I have for professionals who are designing and building these things? It's a good question. I think it's really about understanding how it's going to be built later on. If you can understand how the artists and how the contractors are going to build the stuff and start thinking about how to build that in SketchUp the same way, Like start with the foundation, start with the structure, and kind of work your way up the same way you would actually build it in real life, it starts to become a little bit easier. When you just start to make up a wild-ass concept and try and build something crazy without figuring that out, it becomes harder down the line to explain how you want this thing built. So that, I would have that. That's a very good question. Come see me for a prize. Yeah. Yep. So strategies for reducing complexity of models from the 3D warehouse. Really, it's about going into the model and seeing what they built and deleting the stuff that you know you're not going to need. If you're putting a space shuttle in a project, for instance, because we designed the Kennedy Space Center Home and Museum in Orlando, outside of Orlando, and they had taken the model from the 3D warehouse of the space shuttle and stuck it in the model, and the model started to get massive. And I went into the model, and like every button and control panel and the seat belts, like all of that was still in the model, but they had taken the model and they had shrunk it down to a tabletop size because it was for an exhibit. And it was basically the entire model of the space shuttle sitting on a table, and I didn't need it. So I went in there and I deleted all those everything on the inside, and it shrunk the model by hundreds of megabytes. So just go in and look at it, see what you don't need, delete it. If you don't need the textures, get rid of the textures. Use the Purge All extension to purge everything. Purges components, purges layers, purges scenes, and purges materials all in one shot. Purge All. I use it every 10 or 15 minutes and cleans up my models. Yeah, make sure you do that. Question, yeah?
We have a suggestion about what's important on a new laptop.
What's important on a new laptop? In addition to the processor speed, it's really the video card. It's my recommendation. The video card makes a big difference. I mean, more memory is better, obviously, but you don't need tons and tons of memory. It's really the video card and the processor which is going to speed you up. Yeah. Questions? Come see me for prizes. Yeah. So I haven't used a lot of dynamic components. I don't really understand how to build them. It's actually pretty complicated. There's a guy named Eric Schimmelfinnig who you need to go see if you want to learn about dynamic components. He has a couple sessions here. And there aren't a lot of there's a lot of dynamic components out there, but not for the stuff that I need, right? There's a lot of dynamic component windows and doors and things, but I don't really use a lot of those dynamic components. And they're not at a point yet where they're super easy to build, which is why I think more people aren't making them. Yeah. Yeah, there are extensions for controlling the projection of the image on the surface. I'm coming up blank on what they are. Justin knows. What is it? Oh yeah, Through Paint, THRU, Through Paint, and it has all kinds of features about how to control the texture of an image, and it does it so it doesn't splinter and get all crazy. It's really powerful. Yes? He's right there. Justin Geist, he's right there. Stand up again. He's got a bunch of classes, take them. He's a whiz. He does, I showed you, I talked about 20 extensions. He did 60 in an hour. It was one a minute. It was it's crazy. What time? Tomorrow at 9:30. Yeah. Yes. When it gets exported out, it's an SKP file. So we're using lots of different software, and we export FBXs, OBJs, 3DS, SKP, it depends. The thing that we found helps the most for interoperability between software is SimLab Composer. There's a piece of software called SimLab Composer, and it optimizes, it maintains your layers and your textures, and it allows you to translate from one piece of software into another piece of software very, very well. So a shout out to SimLab Composer. Yes? Have we ever tried making physical 3D models? Yes, we have done some 3D printing. It's because of all the curved shapes and all the crazy stuff, it becomes challenging because you got to make sure everything's solid and watertight. And you can use Solid Solver and some other extensions to allow you to do that. It is difficult, but yeah, we've printed 3D stuff. some crazy 3D stuff, sure. Yeah, in back. What are the top 3 extensions? This is like that, the ones that you need to get your job done. Those are my top 3 extensions. I love the Instant Suite, Instant Fence and Railing. It literally saves me days worth of time. I use Put on Layer a lot. I'm really, really organized. I have a lot of layers in my files. And there's an extension called Put on Layer that makes it really easy, way easier to move an entire group of things. It digs all the way down into groups and subgroups and puts everything inside of a group on a layer. So I can really control what objects are on what layers. And then I use scenes to manage my layers. If you come to my workshop tomorrow at 1:15, I'll talk about both of those things. Yeah. Yep. Yeah. Yeah, there are some extensions. I don't really work that way. Justin will probably have more answers than I do. But it's a little bit trickier because it's not a solid modeler, right? There's some other pieces of software that are better sort of at solid modeling. It can be done, and there is some software to do it, but SketchUp's not really a solid modeler, so it's challenging. It's not really designed for that, but it is possible. Sure, it's possible. Way in the back. So what do I make my own materials, or do I, like in the model itself? So typically we have a visualization team in our office, and typically I'll put a material on so that they know what my intention is, like whether it's wood or metal or steel. But then when we get it to the visualization team and they're putting it in Lumion or they're putting it in the Unreal Engine, that's where we're really starting to deal with materials and really get specific about material and textures and reflectivity and color. So I'm really just kind of giving them a guideline. And so I don't really make a lot of custom materials because our visualization team can take it to a whole other level that I just don't need to spend the time doing. Anybody else? I think we are probably done. It's 1 minute over. If you ask me a question, come up. I got a t-shirt for you. Thanks, everybody. What size are you?